Welcome, welcome, welcome. So yeah, I was just looking for music to play today, and I didn't realize that. Like I'd been using Riot Games sessions, which is the creator safe playlist, but they've also got, and I just discovered this just giant, massive playlist containing not just the sessions, but containing a whole bunch of other music that they own, and they make available for free for content creators. It's pretty great. Yeah, so I guess we'll listen to that a little bit. Pretty high energy stuff at the beginning. But yeah, let's let that run in the background. Anyway, welcome. I'm not going to be doing much feature work today on the game engine. It's a Saturday morning, and I just kind of had this itch to fix a problem that we've been dealing with in the last stream. So let's review where we're at. Yesterday, we got the hierarchy panel to populate with details about the scene that we have open. So inside of the editor, I open up the scene file. We got the interactive camera controls now, and I created a simple scene that had a number of items in it, so we could play around with the whole selecting multi-select feature inside of the hierarchy, and that's working pretty good. However, there was this weird problem where we started seeing Madeline all over the place. And when I made this file, I was actually expecting to see just the same row here, Hollow Knight, Link, and Madeline, be copied up and down a couple of times. But for some reason, this column that's supposed to be Mr. Knight is all Madeline, and same thing for Link. So I figured I'd spend a little bit of time this morning addressing that. Before I do, though, I just want to quickly touch base on a few things that have changed in the hierarchy panel since the last stream. There's a little faint border going around the last selected item. You can see here. As we talked about during the last stream, we set up a system by which you can shift click from the last single selected item. I now am calling those in the code. I'm calling those shift anchors or shift select anchors. And this is sort of a thing that you see in Windows, where if you find a list of stuff, like let me open up a folder with some stuff in it. So like this is the root directory of the enterprise solution. You see that when I select this one item, we have this little blue border, this dark blue border around the blue selected region. And if I shift select, the last selected item here, which in this case is the gitignore file, has that border now. And what Windows is signaling to you is that that's the item about which shift select will continue to select. Or at least that was my first read of it. It actually is a little more complicated than that. It highlights the item that was most recently selected, but if you continue to hold shift and select around, it'll actually continue to use the last shift anchor. I did something a little bit different where when you see the little border, that'll tell you that that's the item about which you're going to select, which I find really useful in creative applications. So for example, if I click the first item, I hold down shift and I select a couple, I can now hold control click, select another item, and then shift click from there. But yeah, I just needed to make that item stand out a little bit. So in the IMGUI code, I simply added, where is it? Here. I simply added a rectangle. That's the color of the styles border color around the location of the selectable. But yeah, other than that, it's pretty much the same. But let's take a look at this bug. So let's take a look at the EB project file, the EP scene file, this guy. So this is the actual YAML file that we loaded to make this scene appear. we went over the structure of scene files a little bit before. Basically, it's just a entity ID, name, position, rotation, and scale. That these are the core elements of an entity. Every single entity in Enterprise has them. However, if you want to add components, the system that's in charge of those components has its own space within the scene file to define the attached components. Each system can decide how it stores the files. Basically, we just give it a block for its memory, and we give it a section for each entity that it has a component attached to. So these are also very simple. These are the IDs that we had up above. So they're an exact match for the entity IDs that these components are connected to. And then we have, for my simple 2D renderer, we just have a path to the texture file. We have the listing of the UVs, the left, right, bottom, and top UV bounds. And then we have a listing for the minification filter, the magnification filter, and the MIP map mode. Yeah, it's bug season, Joel. I just realized, though, that I don't have my Twitch overlay here. Let me throw that up. There we go. Now I should be seeing your messages on the feed. But yeah, so each one of these, we have text 1, text 2, text 3, text 1, text 2, text 3, and repeating. You'll see the pattern. But for some reason, we see a bunch of Madeline, and I don't know why. So let's dig in, I suppose. So for me, the most logical place to check in would be to take a look at the actual rendering code. So let's go to renderer 2d.cpp. This is far from any renderer that I might ship with Enterprise. And frankly, I only have it here to make it possible to develop the framework within which to write a renderer. So this is all very primitive rendering code. There's not a lot of code in here. When we go to do the draw call, scene draw, we basically just invoke this method, draw sprite components. Draw sprite components starts a sprite batch, goes through every single sprite component inside of the component pool. So that's up here. Should be, yeah, sprite components. It's a vector of sprite components. That's the size of the maximum number of sprite components. And this essentially serves as a pool. We have a map that associates entity IDs with an index into the pool. And then we don't have to allocate one of these every time we want to add a sprite component. We just grab it from the pool. I like pools. Pools are great. But yeah, so let's find where we do the draw sprite call. That would be here. And I'm just going to set a breakpoint somewhere in there, and we can confirm everything is working the way we expect. All right. So I'll probably have to step through this a couple of times. The first thing we've got is a draw sprite with a texture handle of 4, and I believe that's I'll have to take a look at the texture code to actually identify which texture handle that's for. But let me, on the left-hand side here, I'm just gonna add to the watch window the parameters that we care about. So we're keeping an eye on which texture it is. I suppose we don't care about the bounds of the UV or the position, rotation, and scale, because those seem to be correct. The only thing that seems to be wrong is that we've got Madeline all over the place instead of the variety of characters that we're rendering. So I'm gonna step over, I'm gonna hit continue and continue on to each next sprite and watch the texture value change in the watch window. So we were at 4, now we're at 5 and 6. Now we're back to 4, 5, 6. Okay, so it kind of seems like the texture being passed in to the draw sprite call is correct, because it's cycling between 4, 5, and 6, which I can presume would be for the Hollow Knight sprite, the Link sprite, and then the Madeline sprite. However, I don't have to guess. Let me go back to the scene file. There we go. So this is the scene file in question. And if we take a look at the sprite ordering, sprite 1, 2, 3, we use text 1, text 2, and text 3. And those sprites are... okay, the first one is, it looks like it's Madeline. So text 1 is Madeline. Text 2, that PNG, is Link. And then text 3 is Hollow Knight. Oh, hang on, that's interesting. Okay, yeah, never mind. I was thinking that it was interesting that they were ordered Hollow Knight on the left, even though he's text 3. But actually, it turns out that I just have the ordering of these sprites backwards, so I have it going right to left. If that's the case, it seems to be that when we draw the other sprites outside of the first row, they seem to be going back to texture 4. And I don't really have a good explanation as to why. Alright, so it seems clear that as we cycle through these, that the batch, the draw sprite call is being told to use the correct texture. It's just that we're not actually using the correct texture. So I'll stop on one of these 4, 5, or 6 sixes, because the 5s or 6s, because the 5s or 6s are presumably the ones that are showing up incorrectly. Number assigned sampler slots. Let's step through the code a little bit. So first thing we have when we go to draw a sprite is we have this sampler slot algorithm. So in OpenGL, you don't have to just bind one texture and then do a draw call with just the one texture. You can bind up to a certain number of textures at the same time. I call them texture slots. They're called texture units in OpenGL. And the idea is that you bind each texture that you need for a single draw call to a different texture slot or texture unit. And then from there, you can reference them in your shaders simultaneously. So I use that in my batch rendering because you don't want to be doing a draw call for each sprite. You want to be doing as few draw calls as you can. So what I do is I load up all the textures that I can into a texture slot. I bind them to all the texture units we have available. And then I simply pass those handles, like the ID of the texture unit, to the shader. And the shader can dereference out of the available pool of textures the one that it needs. So I kind of do this round robin assignment thing, if I'm remembering correctly. So we start with just looping through the number of assigned sampler slots, and we're basically searching for a sampler slot that already contains or already has the texture that we care about bound. If we do find it bound, then we use it. Otherwise, we need to assign it a slot. So that's what this loop does here. Instead of declaring the I iterator inside of this for loop, we set it outside, and then it's available for checking in this post for loop block. So inside of the for loop, we iterate through all of these sampler slots. If we don't find the texture, then we can assign it here. So this is a check to say if I equals num of assigned texture slots, meaning that we've exhausted this list without breaking. Because if we break, then I will still remain equal to whatever lesser value that is. Then we go through, we end the current batch, start a new one, complete a draw call, and then start binding samplers all over again. And that seems to be what we're doing here in this case. Which is actually very surprising. I was not expecting that this would ever be invoked. We've only got 3 sprites, and on this platform we've got, scrolling up a little bit, we've got 32 available texture slots, so we should not be exhausting that and executing this code at all. Maybe I've misunderstood how I utilize this value. Okay, so number of assigned texture slots, that's something specific to the 2D renderer, it looks like. So when we go to begin the batch, we set that to 0. And then as we start using sampler slots, we track how many that we've used. Okay. I have this guard here, I is greater than or equal to 16, because even though most platforms will support many more texture slots, for example, my computer supports up to 32, it is a hard-coded limit in the macOS implementation that you cannot have an array of greater than 16 sampler 2Ds. Which is annoying. that's a GLSL implementation detail on macOS. But until I graduate from OpenGL on macOS, we have to obey that limit. So if we're utilizing more than 16 slots, then we have to start over, and we end the current batch and we start the next batch. Okay. If we were to do sorting on the input stuff, then this would result in fewer draw calls. But again, this is a very fundamental, basic renderer. So how many times do I reach this point? I'm gonna move my breakpoint to the inside of this block, and start over. Open the scene file. Okay. And then we've got bind 1, 2, 3, 4. Yeah. Oh, you know what? Okay, I think I've misread the code. So actually, I should be hitting this section of code 3 times per draw call. For texture ID 4, texture ID 5, and texture ID 6. Okay, that makes sense. Okay, I think I'm following what's happening here. Cool. So we tell graphics to bind the texture. We set the sampler slot ID to the texture. And if I set my breakpoint at this location and I just sort of pay attention to what we do with sampler slots at I. This will give me a good picture of how we're utilizing these sampler slots in GLSL. Okay, so on the left here, I've got the watch window is watching the sampler slot elements. And actually, I'm seeing pretty much exactly what I want. 0, 1, and 2, the first 3 elements of the sampler slots, is being assigned texture IDs 4, 5, and 6, which is correct. We should only see up to 3 of the slots being used, and they should each slot should be populated with one of the textures that we are using in this rendering process. So that actually looks fine. So I'm wondering now if the issue is even farther down. Maybe there's an issue with how graphics bind texture works. Okay, and then the rest of this is apparently pushing stuff into the vertex array. So we just set the position, we set the model matrix. We're now setting the UVs. Where do we set the, do we set the texture ID inside of here? Let me take a look at the structure of quad vertices. Right, so this structure here represents all the data associated with a single vertex for this renderer. It's very simple. We just have the position, the location in the world space of where the vertex is. Or I should say the position in object space. No, world space. That's right. The vec2 representing the UV coordinate on the texture. So we can do sprite sheets this way by using non-corner, like moving the UV coordinates around. And then we have the texture ID, and this is how we actually look up which sampler to use from this slot mechanism. I think that last element in texture is not being updated here. in_tex. Yeah, so first, in the situations where we find that the sampler slot is already there's already a sampler slot that contains the texture we want, we set the in-text variable to be equal to that slot. And then next, if it doesn't equal, like if we don't find the assigned slot, then we bind the texture, and then we pass in the excuse me. Then we pass in the index. However, in the situation where the texture has already been correctly loaded, I don't think we're actually populating the texture correctly. This might be the problem. So like the first 3 sprites, like the first 3 sprites being the first time we used each texture, would have the correct slot be passed to the shader, and everyone after wouldn't, and that kind of explains what we're looking at. The first 3 sprites look correct, and then every other one uses the wrong texture. Just looking at this, studying this a little bit to make sure that I'm on the right track. So we're hunting for the slot. If we find it, then quad vertices I times 4 plus 1. I think there's a problem with this code, actually. Yeah. In-text is the sampler slot index. What's up? And welcome, by the way. So here's what I think the problem is. I am using the I times 4 plus whatever. However, sprites to push is the index into the quad vertices that I've been using for all of the other stuff. And I here should represent not anything to do with the quad, but it should represent the slot index. So I guess this just must have been a typo that I never caught. And so the first three, the first instance of each texture use was being set correctly, and then after that we were passing, we were not setting the correct value for each of these. That's my guess. Yeah, so it's a, there's some unseen stuff at work here. I've mentioned a couple of times that Enterprise's main focus is the framework, not a renderer. So the idea is that my actual Enterprise low-level API is designed in such a way that you can make your own renderer quite easily. So bind texture takes and accepts a texture slot, I believe. Yeah. So we pass in the texture handle that we want to bind. We pass in the name of the sampler that we want to bind it to, and then we pass in the slot. And basically, this will allow you to not have to worry about associating the name of the texture with the name of the sampler array. It automatically finds the introspects the correct name for the sampler array in your shader and links those things up. Oof, got a mosquito. Yeah, so actually, I think that's probably it. Let's compile and confirm that this actually does what I think it does. What's the problem? It says build finished with Xcode -1, but a CMake task is already running. Oh, it's in the middle. It was already, I just was overzealous and kept pressing F7. It was in the middle of compiling something. All right. And open scene. Okay, and that's my breakpoint. That's not an error. Yay! Okay, yeah, that was actually a really simple bug. I'm glad it was. And that only took 30 minutes. So now I'm wondering whether I want to stay on and do more work or if I want to just call it a stream, because this is the only thing I wanted to do this morning. Anyway, let's yeah, save that change. I guess we can go through and commit the stuff we've been working on. So taking a look at the renderer 2D stuff, I'm just going to quickly push the fix that we implemented here. Yeah, that would be everything in this file. Stage that. I added code to Renderer 2D to do to bind the simple material shader before use. That's not going to be committed. That's just something I have going on right now to test the framework. Eventually, I'm going to need to add a actual material system to the renderer, but that's a tomorrow Michael problem. So yeah, let me just quickly save that fix. Fixed issue with rendering one character over. Fixed multiple texture render bug in renderer 2D. Will that fit? Yeah. Fixed multiple texture render bug and render 2D. Sweet. And then let's take a look at the code we did yesterday. I'll need to make some changes. Yeah, so in order to commit the changes we made to the hierarchy view, I need to commit some changes that we made to the scene manager. So first thing is that we are now storing the actual name instead of the hash name of the entity. We now have these modifications to create entity, where we accept the name as an optional. And then if the name is not provided inside of the create entity, then we will make the name unnamed and then in parentheses pass out the ID of the entity. And the rest should be fine. Okay, and then we have the get entity name, which we didn't have at all before. We have the get all entities, which we use to populate the hierarchy. We have this modification is to get the string name instead of having to call the unhash method at hash name to string. Same deal here. Same deal here. Okay, this file is ready to commit. Scene-manager.h. We now include std optional. We've made a modification to the create entity method. The std optional itself has a default parameter of std null opt. And then, yeah, we added get entity name. The documentation looks fine. And then we added get all entities, and that looks fine as well. So this file is ready to commit. Bam. This change was from an experiment I did yesterday. I can discard that. Cool. All right, and this is all the work that we did in the hierarchy. So let's open the file directly, just quickly proofread. So I'll use Alt-Shift-F to apply the Kling format. Hierarchy. Then we have, so the way that I lay out my headers is that I will have, whenever I'm doing an implementation file, I'll have the header that we're implementing be the first header that we include. And then I include my C standard library stuff, then my C++ standard library stuff, then my C standard library stuff, then my third-party vendor library stuff, and then any includes from the project in question. So in this case, we're using a precompiled header, so I don't actually have to include any of the standard library stuff that I normally use. I just include the header that I'm implementing, views hierarchy.h. And then the third-party stuff, and in this case, I am very much including the enterprise headers in this category because we're consuming the enterprise library. I'm GUI is kind of an edge case because technically it's an external library, but it's being compiled into this library as source code. So I put it up next to the other library headers. And then I have the headers from this project. And in this case, it's just layouts/sceneeditor.h. I'll separate it like that. Entity select status bit field. Yeah. I went and renamed some of these things after the stream yesterday. And these comments seem to be pretty nice. Good. We got the border around the most recent shift anchor. This is pretty clear. I was thinking about this when I was reviewing my code yesterday. This is actually probably not the most efficient way to handle this problem. So this is referring to when you go to do a shift select. Let me build real quick. Yeah, after I've committed this stuff, I'm gonna just go ahead and call it a stream because I thought that the bug that I was hunting would take a little bit longer to hunt down, to be honest. And I don't really want to work on feature stuff today. I've got other projects I've got to work on. Oh yeah, I just changed a CMake file, so this is actually gonna take a minute to compile. Basically, I just removed an element from my precompiled header, and because of that, it has to recompile a whole bunch of translation units. Almost done, though. There we go. Cool. So if we go to open scene, yeah. What was I talking about? Yeah, so in the shift selection stuff, when you hold down shift and then select another item, this logic where we identify, where we set the bit for each of these items in the range, the way that I implemented it immediately was just to loop over every element in that range and set its bit. And that's a totally fine way to do it, but it's occurred to me that I could totally instead have just constructed bit masks for every bit field we need to modify, and then just set bitwise or them one by one, and that would mean that we would cut out, like if I was shift selecting like, you know, hundreds of items, that would potentially reduce the number of loops in here dramatically. But I figured I'm just going to leave it as it is, instead of actually bothering to set up the logic to do that optimized way, because this is not going to be invoked all that often. It's only invoked whenever you shift click, and it's not likely to be a huge stall if we have a bajillion items and we shift click most of them. So yeah, this is a case where I'm intentionally skipping premature optimization. Yeah, this seems to be pretty good. I'm not actually using cleanup for anything, but it's a core call. I'll leave it in there, and init as well. I'll leave these in here until I decide that I'm never going to use them. Yeah, so hierarchy is ready to commit. And we didn't even have to change the header on this. It's just the very simple init draw cleanup calls. Okay. And the only things that are left uncommitted are, well, there's the test game stuff, but that's by nature. I'm not going to commit that. But then there's the the render2d.h, which just added a cleanup call, and render2d.cpp, which is where we implemented the simple material system, and we don't even care about that anymore. All right, cool. Everything's looking pretty sweet. It's coming along. I'm getting really excited about this project. It's getting to the point where we're starting to do some cool stuff. The next things we'd be looking at would be actually setting up the inspector to display details about the selected components or selected entities, and then we can from there add in widgets that will control their positions and rotations and things. And then we're just going to start adding features one by one to make this editor actually useful. Cool. Let me put a commit message on this. Or added entity population in hierarchy view. And that's a good message. Sweet. And I'll go ahead and sync these up to the cloud now. It'll probably be worthwhile for me to, on my MacBook, I'll sync up and compile and make sure everything is working fine on my MacBook as well. I don't normally do that kind of stuff on stream because it's just, at this point, there's not a whole lot of implementation work that has to happen on macOS. It's just what we did on Windows with a couple of things changed. But yeah, all right. Thanks for joining me this morning. I hope you have a great rest of your day. I'm gonna go pour myself some more coffee and probably work on some sound design stuff for a project that I'm working on. Have a good one. See you later.